Hello everyone, welcome to my channel. Today let us learn about the subject Automata theory and compiler design. The topic I am going to discuss today is compiler design and its phases. The contents we discuss today is Introduction to Compiler Design, Phases of Compiler Design, and the conclusion. Introduction to Compiler Design. There are two phases in compilers, namely analysis phase and synthesis phase. In analysis phase, from the given source code, it creates an intermediate representation. In synthesis phase, from the intermediate representation, it creates a target program. A compiler is a software program. It converts high-level source code, which is written from a programming language, into low-level machine code that can be executed by the computer hardware. The process of converting the source code into the machine code involves several phases or stages, which are collectively known as phases of compiler. So, let's learn about the phases of compilers design. The first phase is lexical analyzer, syntax analyzer, semantic analyzer, intermediate code generator, code optimizer, target code generation, error handling. From high level language to it converts into assembly level language. Let us learn about the phases one by one. The first phase is lexical analysis. It is also known as scanning role. It breaks down the source code into tokens, which is the smallest units in the program. And example for tokens are keywords, identifiers, literals, operators. Lexer. Lexer. The role of Lexer is to scan the source code character by character and to categorize the tokens and recognize it. It uses a regular expression. Lexical rules are often defined using regular expressions. The output of lexical analysis is to produce a stream of tokens for further processing. The second phase is syntax analysis. It is also called as parsing. Purpose: it organizes the tokens into hierarchical structure, that is parse tree or abstract syntax tree based on the rules of the programming language. Syntactic rules of the programming language. Syntactic means it follows a syntax. What is parser? The parser role in the syntax analysis is to check the tokens, which resembles the grammar rules. Grammars. Context-free grammars defines the syntax rules of the programming language. The output of syntax analysis is a parse tree representing the syntactic structure of the source code. The next one is semantic analysis. Purpose is it checks the meaning of the statements in the programming language. Type checking. It ensures that variables which is used are in the manner consistent with their types. Scope resolutions identifies the scope of variables and enforces scoping rules. Output: an annotated syntax tree with additional semantic information. It contains additional information of the semantic. Intermediate code generation. The purpose is it produces an intermediate code representation that is independent to the target machine architecture. Advantages is it simplifies the process of the code optimization and facilitates portability. Examples: 3 code, 3 address code and byte code. Output is intermediate code for subsequent optimization. The next one is code optimization. The purpose is of code optimization is it applies optimization technique to the machine code which improves the efficiency of the generation. Techniques used is constant folding, loop optimization, inlining and dead code elimination. Trade-offs: balancing optimization against compilation time. Output is optimized intermediate code. The next one is code generation. Purpose: it translates the intermediate code into machine code specific to the target architecture. Instruction selection chooses appropriate machine instructions. Register allocation assigns variables to the registers. Output: assembly code or machine code instructions. The next one is code linking and assembly. Linking: it combines separately compiled modules into the single executables. The codes which are compiled in the separate modules are combined to single modules. Address resolution: it resolves the addresses and establishes connection between different parts of the program. Assembly converts assembly code into machine code. Output, final executable code ready for execution. The output of code linking at assembly is it prepares the final code for the execution. Error handling. Throughout compilation, it detects and reports errors during all phases of compilation. Error handling plays a role in the phases of compiler design as it detects the errors in all the phases of compilation. User feedback provides meaningful error message to assist programmers in identifying and fixing the issues. Error handling makes sure that it provides a meaningful messages. It provides a error messages for the programmers where the programmers can identify and fix it. Error recovery strategies for recovering from errors to continue compilation. Conclusion. The compiler design is the most important cornerstone of the software development. It offers a systematic and transformative process which converts human readable code into the machine readable machine instructions. The careful orchestration of the various phases ensure the accuracy, efficiency, and portability of the final executable code. Thank you, everyone.